Hey, you tens! Thanks for coming, guys. Do you know what? I always look forward to these lessons. It's always so you're always watching, or when you've just been an absolute star. You guys know exactly what I'm doing and how it all works, and you guys are just brilliant. Thank you so much. So, is Isabel here yet? Has anyone seen Isabel? Victoria? Roomings live in 11 hours. RIP my power at home. What? Roo? What? Good. He's just lost me. Toby's in the house. Love it. Toby's in the house. Ben is. Vixen. Yeah. Smashing it. Where's Isabel? Come on, Isabel. Where are you? You're watching. Roo, you know what I'm going to ask? Can you ask if Kieran's here? Anna's in the house. Yep. Shanley's in the house. Rue's in the house. Has anyone seen Harry's? Kieran's watching. I thought he might be. He's so funny. I am missing. Harry's is in there. Where we go. We're nearly there. Just Nick, Ashley, and Isabel to go. Poor Kieran. What are you saying poor Kieran for? He's too lazy to sort out his YouTube channel. Don't say that, Shan. Kieran knows exactly what he's doing. Oh, it's funny. I'm just missing Nick, Ashley, and Isabel. Come on, guys. I'd love to be done in under 2 minutes on the register. How good would that be? Come on. Come on. Somebody message Isabel, will you? Oof, Kieran. I know, right? I know. Isabel, Nick, and Ashley. That's who we're waiting for. Nick's in the house. Thanks, Nick. Yo, Nick. Sup, dude? Sup? So, Toby, what if Mr. Duncan did his entire lesson in a Scottish accent? Not very good at the Scottish. I'm not very good at it. I can't do a Scottish accent. Do it in Leeds. A Brummie. Could do a Brummie accent, but not very nice. I don't really like the Brummie accent. It's a bit slow. I wish I could do Scottish. I need to work on it. I need to watch some of those videos on how to do a Scottish accent. I also really want to learn to do a Geordie. Geordie. Love to do a Geordie. Be amazing. Yeah, so I'll work on that just for you, Toby. I'm on it. Sounds a bit funny. Isabel! Oh, look at that. Isabel, she's rocking up like 5 minutes late. It's like, hello, I'm here, don't worry. Thanks, Isabel. So the only person that I'm missing now is Ashley. Oh, there's Ashley. I love that. Ashley, you just arrived like a proper queen. She walked in going, I have arrived. But we're all here. Winner. Look at that. You guys are always so good. I was 2 mins. 2 mins? It's 38. Started at 35. You're 3 minutes late. Okay, guys, we're off. So, guys, we finished off calculations today, and the test has now been made, trialed, and it's all good to go now. I'm quite excited. Yeah, so I'm going to be setting you guys a homework at the end of this lesson. I'm giving you guys a homework on excess reagents because I know they're tough. They're really tough. Only 7 questions, dead easy, just to get it done by Monday. And over the weekend, I need you to be doing some, and it's Wednesday today, you've got tomorrow off. Amazing. Friday, you're not in school. Mate. Oh, actually, I'm in Thursday. No, hang on. You're in school on Thursday, just science isn't in on Thursday. I think that's right. Do I have you guys period 6? I'm teaching period 6, that's all. Oh, I don't even have a lesson period 6. I might teach you period 5. Ooh, might be here period. Wait, Mr. Duncan, what's going on tomorrow? So tomorrow, I've got a big science meeting tomorrow all day. I might be free, though, period 5. I'm not sure yet. Yeah, and I've got you guys period 5, so I'm hoping it'll all be done by then. But I'll post some questions, some revision questions for you guys to do on calculations. But I'm just letting you guys know that your online test is going to be next Wednesday. Your online test is next Wednesday. This lesson, you will have 1 hour to complete it, and I will be watching you all do it. Yeah. We're going to do Google Hangouts. You're all going to share me, and I'm going to watch you all do the test. 20 questions. That's all it is, folks. Yeah. But you guys are going to smash this. So, guys, it is just one question on every calculation type. Yeah, just one. 20 questions. That's what it is. Yeah, and so you need to be doing some revision over this week. Yes, you've got a full week to revise, folks. I'll send out a booklet of questions. Yeah, I'll give you the excess reagents, but I'll also include a revision booklet, which includes all the questions. The online test is a Google form, and all you have to do is put in your answer. That's it. Yeah, that's it. I don't know why you wrote goat. I have no idea why you wrote goat. I'm gonna say anyway. Let's do excess reagents and not get bogged down with your test. Okay, we're off. We're off. Hello, we're in. Scottish. Need to work on it. Definitely need to work on it. I should have figured out how to do a Scottish accent during lockdown. It's my task. Right. Okay, guys. Just gonna make sure that you guys are seeing what I need you to see. Yeah, it looks all good to me. Right, so we left off doing percentage yield. So, and our title was excess reagents. So I'm going to add on a little sheet here, and we're going to do title is excess reagents. So we don't have to do any review of questions, I don't think, today, because I haven't set you any. I think that's right anyway. But this is whoa, didn't mean to do that. There we go. Excess reagents. Excess reagent calculations. Calcs. Okay, so learning objectives for today's lesson. Number 1 is I need you to be able to recognize an excess. see what I've done there? The excess. Be able to recognize an excess reagent calc. So the first thing is you've got to be able to spot them. Yeah. Number 2 is understand moles and ratio. Yeah. And the last one is be able to determine excess reagent. Determine excess reagent and calculate product mass, product quantity. I'll put quantity because it might not actually be quantity. There you go. So those are my 3 learning objectives for today, folks. And this will bring us to the end of calculations. Okay. So the first thing we need to do is how do we recognize an excess reagent? Yeah. So let's do a question. So in question number 1, if I did copper reacts with oxygen to form copper 2 oxide. Yeah. And let's balance the equation 2 and a 2. So if I said 10 grams of copper, how much copper oxide? We are in that particular question there. Everybody will all realize that what I have not done is I have not told you anything about the oxygen. We are making an assumption. What's after calculations? Acid-base theory. That's what it is. Rue? Good question. So I am not, when I give you this, this is a bog standard reacting mass question. Yeah? This is a reacting mass calculation. And you guys can all do this now. You go get to moles, use the ratio, get out of moles. Yeah? But we are actually, in fact, making a huge assumption. The assumption, this is a nota bene. I'm tempted to actually write down nota. I think it was nota bene, like that, I think. Latin for important notice. We are actually making an enormous assumption. What we are assuming is that the oxygen, nota bene, oxygen must be in, and this is the first time we're using the word, excess. So what does this word now mean? This word, excess, excess literally means more than enough. Yeah. Some people don't like more than enough. Some people just like this, too much. Yeah. Some people, when I first started teaching, I used to always teach more than enough. And then all of a sudden, one of the students put their hand up and said, I don't really understand what you mean by more than enough. And I said, oh, there's too much of it. And they said, oh, okay. So you've just added too much. And I'm like, yeah. And they're like, okay, I get that. So I've added more than enough. I've added too much oxygen. Yeah. And that's what the word excess means. Okay. So there is another word that we need to now mention as well. So there is excess, too much. And there is also limiting reagent. By the way, reagent just means is the word given for something that goes into a reaction. If you like, I could have put limiting reactant if you prefer. Yeah, limiting reactant. So the limiting reactant, what does this mean? So I'm going to put this one here goes in a red box. And then I'm going to try that again and not overlap into the other one. There we go. So excess means too much. Limiting means not enough. It means not enough. One is more than enough, and the other is not enough. Yeah? So what's the opposite of too much? Too little. Yeah? I have too much of it, and I have too little of it. So at this point, students go, okay, so there's two different words here. One where I say there's too much and one where I say there's too little. So here's the next question. Which one matters? So out of these two, question, put it on the chat. Which one will I ignore? Which one of those two boxes will I just ignore? I'm curious to see how many of you get it. Put on the chat when you think you know. Is it too much or too little? So Shan thinks I'm going to ignore limiting. Rooming thinks we're going to ignore excess. Tong thinks excess. So I've got 2 excess, 1 limiting. Ruby thinks excess. So 3 for excess, 1 for limiting. Keep going, guys. You're doing great. Ashley, excess. Harris, limiting. Any more? So I've got 4 for excess, 2 for limiting. Win, limiting. Excess for Victoria. So I've now got 5 excess, 3 limiting. Yeah. I've got 5 for excess, 3 for limiting. Toby says excess, 6 for excess. Isabel says excess, 7 for excess. Con says limiting. Ben says limiting. Oh. How fascinating. What a great game this is. You do realize there's only one of them. So one group of people is definitely going to get it wrong. Yeah? So the question is now, folks, do we go with the consensus, which is 7? And the answer is, that is correct. Yeah. Which do I ignore? And the answer is excess. Yeah. The reason being, so I ignore excess. The reason being, let's try and put this into an analogy. Yeah, Tong, that's so great. I love that. Yay. Oh, Win, don't be sad. Oh, don't be sad. Imagine this. Imagine we're going to make 5 cupcakes. This is right up Shan's alley. Yeah? And on the top of those cupcakes, I have got a cherry. So I'm going to make cherry cupcakes today. Yeah? I'm going to make cherry cupcakes. We're going to make 3 of them. Going to make 3 cherry cupcakes. Right. So my question to you is, Year 10, in order for us to make 3 cherry cupcakes, how many cherries do I need to buy? Now I'm hungry. Oh, it's so funny. Better more than less. Ashley, you're absolutely right. Yeah, how many cherries, how many cherries do I need to buy? Cherries need to buy. Question mark. Answer. And guys, well done. Ruby and Tong have just nailed it. At least 3. But you're not going to buy 3 from the shop, are you? Oh, I get it now. It's clever, isn't it, Shan? Isn't it clever? Yeah? The answer is, I just need to make sure I buy at least 3. You can't buy 3, though. You can't go into Village Grocer and buy 3 cherries. You're going to buy a bag, but that doesn't matter. Yeah? The answer is more than 3. Yeah? But the minimum, the answer is not that. I prefer, yours is better than mine. Tong, Ruby, yours is better. At least 3. Yeah? But in reality, we're going to buy more because more is fine. Yeah? At least 3. Brackets. More is fine. Yeah? But less is bad. Yeah? What we would say, okay, so here's the next question. Here's the next question. Question 2. I buy 2 cherries and all other ingredients. All other ingredients. All other ingredients, ... Who is limiting my cupcakes? And how many can I make? Who is limiting and how many can I make? I'll just eat the rest. Maybe the cake analogy wasn't the best thing to do. Cherries, boys, cherry boys. Cherries are limiting. Absolutely right. Yeah. So the answer is cherries limiting. Cherries limiting. And how many cakes can I make? Come on, guys. How many can I make? Cherries are limiting. Tick. And how many can I make? How many cupcakes can I now make since the cherries are limiting? 2 is the right answer. Answer 2. 2 cupcakes. And the reason being is because the cherries. Yeah, because of cherries limiting. Cherries limit. Yeah? I have ignored all the rest of the reagents because they're in excess. DOS. I love that. Rooming and Toby are literally DOS. Going into Spanish there. Amazing. So what we realize is out of all of this, the one that really matters is this one. The limiter is the one I care about. I don't care about the excess. Stuff the excess. I'm not going to decide how many cakes I can make. Technically more because sugar cherries are horrible. Fake cherries. Oh, God. Let's just ignore the crazy chat, shall we? So, okay, let's go back to our learning objectives. So, be able to recognize excess. Yeah, mole ratio, determining, calculating. I need to also put in here another learning objective. Understand excess stroke limiting. It was on my description of the webinar. Understand the excess limit, stroke excess reagent and stroke limiting reagent. Yeah, limiting reagent. Okay. Tick. Okay, so now we need to be able to recognize it. Okay, so we need to do my first question. My first real question. Okay. recognizing excess reagent calcs. Those are disgusting. Recognizing excess reagent calcs. Right, guys, I'm going to give you two questions. No, 3 questions. No. Question number 1. Copper plus oxygen goes to CuO. Balance it. 10 grams. How much of that? Question number, I don't want you to work these out. Don't work them out just yet, folks. Don't do anything. Question number 2. That's question number 1. Question number 2. Sodium plus oxygen goes to sodium oxide. I've got 20 grams of him, 20 grams of him, question mark. Question number 3. Question number 3. Don't do anything yet, folks. Just bear with me. Bear with me. Grrr with me. See, growled like a bear. No, stop. Next one. Carbon plus oxygen goes to carbon dioxide. Complete combustion. And I'm going to give you I'm going to give you oh, I could be really sneaky here. Oh, 12 grams and 32 grams. Okay. Right, I've given you 3 questions. One of those questions, one of those 3, is a genuine is an excess reagent calculation. One of them definitely is not, and one is a maybe. So I know that seems awkward, that. So in fact, the question I've got to you guys, question number 1, which is definitely not an excess calc? Question mark. I think lockdown is seriously getting to Mr. Duncan. Yeah, absolutely. No, I've just been that crazy since day 1, Shan. I think you know that. You know that, Shan. You know that. Number 3. Rue says number 3. Which is defo not an excess reagent?
Sorry, I don't know that.
Wow, I've just had Alexa chime in. Gotta whisper, otherwise she'll go off again. Ruby says 3. Ben says 3. I'll tell you that one is a yes, one is a maybe, one is a definite no. Which one is not? Ruby says, or maybe 2. 3 for Shan. So far, nobody's got it right. Isn't that a nightmare? Look at the picture and realize who's different. Look at the pictures. Which one is truly different? Yeah? Which ones look similar? 2. Uno. Ruby's on it now. Guys, yeah, you see everyone's on it now. Isn't that interesting? Number 1 is definitely not. This one is not. I'm going to put answer number 1, Q1. And people are going to say why. Yeah? Why is 1 definitely not? Ein? Is ein 1 in German by any chance? I don't know. Ein, fine. Yeah, I think it is actually, isn't it? Eins, fines. I don't know. Anyway. Question 1, definitely not. Why? Question mark. Only 1 mass given. Only 1 mass is given. Yeah, this is the only mass that's been given in question number 1. What that means is I don't know anything else about the rest. which means I have to make an assumption that oxygen must therefore be in excess. Yeah, so that one there is not an excess reagent calc. Yeah, it's just a bog standard reacting mass. However, these two are now tricky because I have been given two masses for both of them. I can work out moles of both. Let's do question number 2. Okay, so we now need to write down nota bene. This is an important notice. I'm going to make my pen thicker. Nota bene. Important notice, folks. If you are given a reaction with moles of more than one. This is so waffly. I hate it when it's waffly. If you are given a reaction with moles of more than one reagent, this seems complicated. It's not. Yeah, I don't like any of this, by the way, folks. I hate it. Reagent, more than one reagent, than excess. Question given. I'll explain. Question given. This will make so much more sense. You'll never have to read that again, folks. I promise. I think that's a terrible little box, that. I hate it. I hate it. I hate it. It's horrible. Yeah, it's easier if I show you. Right. So, question. Sodium reacts with oxygen. Na2O. Balance it. Did I balance it incorrectly? I think I did, didn't I? There we go. Okay, it looks like it's question 4. Okay, and I give us 10 grams of that and 10 grams of that. Right, what I now realize is that I have been given all the information to convert two things into moles. So I can do number of moles as grams over rams. Right, sodium becomes 10 over 23 for sodium. Look it up on my table. Sodium is number 11 and 23. So 23 is the one I'm using. So I've got 10 over 23. I'm converting it to moles. Remember, moles is counting particles. 10 divided by 23. And I get 0.434. Right, next. I've also got 10 grams of oxygen. And oxygen weighs 32. We all know that because oxygen on the periodic table is 8 and 16. The mass is 18, but it's in a pair, so it's 16 times 2, so hence 32. Agreed? So if I now do 10 over 32, it gives me 0.3125 moles. So these are all moles. Now what we realize is that one of them is bigger than the other. Yeah, but the problem is there's a ratio here, folks. There's a ratio. The ratio is 4:1. So 4 of these, 4 sodiums, react with 1 oxygen. So what we're now going to do is we're going to cover somebody up. This is where I need to set you guys out steps. Yeah, I'm going to make somebody disappear. Just going to make this number here disappear for a minute. I'm going to cover it up with my hand, if you like. And I now go, right, well, this is how many sodiums there are, and the ratio is divide by 4. So if I took 0.434 and divided it by 4, I will get a number of 0.1085. Now this number here, yeah, is what is needed. This is the oxygen O2 needed to use all sodium. How much have I actually been given? So this here is needed, and this here is how much I actually have. So guys, here's my next question. O2, excess or limiting? Which one am I? Which one is the oxygen, please? Needed, actually, is it excess or limiting? Guys, can I just point out these questions here at GCSE, these are all level 8 9s. These are the hardest calc you'll ever get. Tong says excess. Wen says excess. Ruby says excess. Victoria says excess. Con says excess. You guys are smashing it. You're absolutely right. Of course it is. The oxygen is in excess. So I can now ignore it. The only one I now need to use is the moles of sodium because the excess doesn't matter. The limiting one stops me making stuff and sodium is limiting. So now I can use the ratio. I'll do it up to here like this. The ratio is 4 to 2. So I'm going to divide by 2. 0.434 divided by 2 gives me 0.217 moles of sodium oxide, Na2O. Now I can convert back to mass, times it by its MR. What does that weigh? 23 for sodium plus 23 for sodium because there's 2 of them, plus 16. No idea what that is. 23 plus 23 plus 16 is 62. Times that by 62. Times by 0.217, and I get an answer of, I'll do this in blue, 13.5 grams, 3 sig fig. Done. Right, so guys, that's your first complete look at an excess reagent calculation. That was actually a hard one, and I do apologize for that. Didn't mean to give you a hard one. It's totally my fault. Let's go for another one. Folks. So, question number 2. Calcium plus chlorine goes to calcium chloride. I've given you an easier one. The reason why is, look at the rate, that is actually now balanced. The ratio is 1 to 1 to 1. This makes everything easier. Yep, that's a good thing. So, I'm going to give you 20 grams of calcium and 20 grams of chlorine. I immediately see these two and go, excess question mark. I've got to run moles of both. Yeah. Steps for excess. Step 1, get everyone to moles. Get both to moles. Get both to moles. Grams over rams. Calcium is 40. Yeah. Chlorine's tricky. Chlorine on the periodic table is 35.5, but it's in a pair. Chlorine's 71 because I've got to multiply it by 2. So over 71. Right. So 20 over 40 is a half, 0.5. So the moles is 0.5 moles of calcium. Next one, chlorine, is 20 over 71, which gives me 0.282 moles. Right, what's the ratio? The ratio is a 1 to 1. So I can compare them directly. Yeah, I can compare them directly. So if I need 1, I need 1. Right, guys? Question. Who is in excess now? Question. Who is in excess? We don't need to worry about now that the ratio is 1 to 1. I don't need to run my other step of doing a cover it up. That's only when the ratio is odd. Con says calcium, Win says calcium, Tong says calcium, Ruby says, you guys are on this today. Well done. Calcium is the correct answer. The moles of calcium is larger than the moles of chlorine. This one is in excess. So I can ignore it. The only one that matters is the limiting. So how much calcium chloride will I make? Yeah, the ratio is 1 to 1. So I'm going to make 0.282. Notice how I just flat out ignore calcium now. Yeah, and now I run my normal process. What does calcium chloride weigh? Well, calcium is 40 plus chlorine 35.5. 35.5 times 2. Yeah, I have no idea what that's going to be. 40 plus 35.5 times 2. Which gives me 111 for calcium chloride. So multiply that by 111. So 0.282 times 111, reorganize grams over grams, and I get 31.3 grams 3 sig fig, and I'm done. Yeah. So you realize that you can't do excess reagent calcs without having already done reacting mass calcs. That's why this one comes dead last. It's one of the hardest ones to wrap your head around, because if it's a 1-to-1, it's easy. You just compare the numbers of moles directly. But if it's in a ratio, you have to do this funny cover-up trick. It's not very nice. Students really, really struggle with this concept. Can I just point out, by the way, these questions come up about every other year. On every other year, you will get an excess reagent question, but half of the GCSE papers don't tend to have one, because this is level 8-9. This is level 8-9. And if they've already done a level 9, level 8 question, then they won't include this. Most students do not know how to do these questions. And it's taken me a long time to figure out a way of teaching it properly. And the best way I've figured out is this cover-up method. Let's do another one. Let's do another one. Question number 3. Right, let's go carbon plus oxygen goes to CO2. Now, I did this one on purpose. I gave you 12 grams and 32 grams. Now, as soon as I see this, I go excess calc. Yeah, that's what I'm running. As soon as I see 2 people, as soon as I see that, I'm like, I know this is excess. That's how I recognize it. Yes? So, okay, what the step number 1 to do, the step 1 is get to moles. Get both to moles. Grams over rams. Number of moles is grams over rams. Carbon weighs 12. 12 over 12 is 1 mole. Oxygen weighs 16, but it's times by 2, 32. This is also 1 mole. Ah, now that's interesting. I have exactly the same number, and the ratio is a 1-to-1. That means I could treat either as excess. It makes no difference. Choose one. Choose the first one. It doesn't make any difference. Yeah, that one I'll use. So I'm going to make, because it's a 1-to-1 to there as well, I'm going to make 1 mole of CO2. How much does CO2 weigh? CO2 is carbon is 12 plus oxygen, which is 16 times 2, which is 44. At A level, 44.0. So times by 44. If anybody's wondering how I know to do times by 44, number of moles is grams over rams, but now I want grams. So I'm going to reorganize, bring the rams over. Number of moles times by rams gives me grams. That's what I'm doing. And I'm going to get 44 grams. They're both exactly the same. Yeah. And so I can just ignore any one of them. It doesn't make any difference. It wouldn't have mattered. Yeah. Next. Okay, question number 4. I'm going to do as many of these as I can as many of them as I can stomach. Question number 4. Hydrochloric acid plus calcium hydroxide. Right? Impress me, year 10. Can you pause the video and can you complete the equation, please? Pause now. Right, now that you've paused it, I'm going to give you the answer. I'm going to form calcium chloride. I wonder how many people got the formula correct. Calcium being a +2, chloride being 1-. And I'm also going to make water. Balance the equation. I need 2 Cls. Yeah, and 2 H's, 2 H's, that adds up. Oh, look, I've got 2 oxygens. So I'm going to have to do that as well. Right, so H's. Ah, there's the 4 H's. That's good. Yeah, and then calcium's 1 and 1. That's good. Chlorines 2 and 2. It's good. And then oxygens 2 and 2. We're good. Okay, so there's my equation. That was a good neutralization reaction. As soon as you see an acid, yeah, it tells you the type of reaction, acid base and neutralization. Right, I'm going to give you, I don't know, 16 grams of that, and 32 grams of that. I don't know, I'm just making it up, giving random numbers. Right? As soon as I see two people going in, I go excess calc. I'm going to have to work out moles of both. And there's a ratio in here. It's going to be a tricky one. Yeah, this is now level 9. It's actually a grade C at A level, just so you know. Most students at A level even fumble these calculations. So number 1, moles. So what is the moles of HCl? What does HCl weigh? Hydrogen is 1, and it's joined to chlorine at 35.5. Total is 36.5. So I'm going to do over 36.5. You do not use the big number 2. That's the ratio. It's nothing to do with it. Yeah? Right. 16 divided by 36.5. And I get the moles of 0.438. Next, what does calcium hydroxide weigh? Calcium is 40 plus oxygen, which is 16, but I have 2 of them, times by 2, plus hydrogen, which is 1, times by 2. So on a calculator, 40 plus 16 times 2 plus hydrogen times 2 gives me 74. That one's over 74. So I've got 32 divided by 74. Oh, they're very similar. 4, 3, 2. Totally by chance, by the way. Yeah. I'll get rid of that G sign, making it confusing. Right. Now, what we'd expect is these are almost identical. And you see that and you go, oh, that one's bigger than that one. But hang on a minute, there's a ratio in here. The ratio is a 2 to 1. So we're going to cover somebody up. Yeah, we're going to cover somebody up, folks. Just make somebody, I'm just going to cover it up with my hand. I'm going to cover up this guy. Just going to ignore that for a minute. Just cover it up with my hand. And I go, right, now that that's covered up, let's just imagine the ratio says that it's a 1 to 2. This would be a times by 2. How much of this do I need? I need 0.432 times 2. I need 0.864. That is needed. This is needed. This is need. Not mead, but need. Yeah, this is needed. Right. How much do I have? This is what I actually have. Actually. Right. The question is now, folks, is hydrochloric acid HCl? Is it excess or is it the limit? Limiting. Which one is it? Cover HCl. Yep, covered up HCl. Ashley, it actually doesn't matter. It doesn't actually matter which one you cover up, because it'll just go in the other direction. Look at you guys. You guys are on this. You totally get it. I'm so glad you do. It's such a... Do you know how long it's taken me to be able to teach this properly? And I still don't think I've exactly got it right, but it's so nice to see you guys go, yeah, okay, I can see this. The answer is I needed this much, and I definitely don't have it. This is the limit. Yeah? HCl is limiting. And I ignore the excess. Yeah, I ignore the excess. So now that I've got that figured out, ignore the excess, use the limit. Yeah? So I now go, so what's the ratio between him and him? It's a 2 to 1. 2 to 1 ratio. Divide that number by 2. 0.438 divided by 2 gives me 0.219. Yeah? Get it out of moles and into grams. Times by, what does calcium chloride weigh? Calcium is 40 plus chlorine 35.5 times 2. Oh, was that 111? That was 111. I remember that. So I'm going to take that number, times it by 111, and I get a final answer in blue of 24.3 grams. Limiting reagents. Do you know what, guys? It's just like anything else in chemistry. It just takes practice. That's it. I'm going to do one more. We've got 10 minutes. I'm going to do one more. I'm tempted to give you a question as a little test question. Whoa, that was a big cue, wasn't it? I was still just as big. I don't know what's going on with me there. Make it smaller. Question. I want to get rid of that 2. Right, let's go for it's gonna okay, guys, I'm gonna make it hard. I'm sorry. AL. I don't want to make it too hard. I've ruined it. Yeah, I know. BR goes to AlBr3, aluminium tribromide. Yeah, balance it. Common denominator for 2 and 3 is 6. It's really awkward. Okay, 2. Guys, I've made it too hard. I'm sorry. I didn't mean to do that. It's really horrible. I'm sorry. I've done it now. I'm sorry. I'm going to give you, I don't know, I'm going to give you 100 grams of aluminium. And I'm going to give you 500 grams of bromine. Oh, this is going to be really tricky. Right, guys, here's your question. What mass of aluminium tribromide will I make? That's the question. Yeah? So I'd like you, please, to pause the video. This is the last one for the lesson. Yeah? I want you to pause the video, run through the process, and see if you can give me an answer. And then as soon as you're ready, you can unpause, and I'm going to go through it. So pause now. Okay. If you still have no idea, don't worry. You can watch me do it. Okay. I know it's excess. Yeah, it's an excess question because I've got 2. Step number 1, get to moles. Right. Number of moles is grams over rams. How much does aluminium weigh? It weighs 27. The 2 has nothing to do with it. That's the ratio. Aluminium weighs 27. So I'm going to divide that by 27. 100 divided by 27 gives me 3.70 moles. Next. How many moles of bromine do I have? Well, bromine, got to find that on the table. Bromine is number 35 and 80, but it's in a pair times 2. So bromine is 160. 500 divided by 160 gives me 3.125 moles. Right. Ratio. We always run this. We realize that everything is based on moles, ratios. It's the same as all the time. Yeah, nothing changes. And then we go ratio. This is the awkward bit. The ratio is a 2 to 3. Choose somebody, anybody. It doesn't matter. Cover somebody up. I'm going to cover him up. Right. If I've covered him up, how much do I actually need? Yeah, use the ratio. How much do I actually need? The ratio is a 3 to 2. Divide by 3 times by 2. So 3.125 divided by 3 gets me to 1. Times by 2 gets me. So I need 2.08 moles. I'm just going to, move the ratio over a bit. Move that over to there. Yeah. This is what is needed. Yeah, this is needed. There we go. How much do I actually have? That is my actual. So the question is aluminium in excess or limiting? And the answer is, if I compare these numbers, I have excess aluminium. Yeah, aluminium is excess. That's correct, Ashley. Aluminium is, yes, Ashley, it is correct. Well done. It's going to be awkward. It is correct. Well done. So I now ignore aluminium, ignore entirely. I go back to this number here. Going to use that one there. The ratio is 3 to 2 again. Divide by 3 times by 2. 3.125 divided by 3 times by 2, and I get 2.08 moles, right, of aluminium tribromide. And now the next question is, what mass do I have? Multiply it by its MR. Aluminium is 27 plus bromine at 80 times by 3. No idea what that is. 27 plus 3 to 80 times by 3. Gives me 267. So multiply that by 267, and I get a mass of 2.08. Gives me 555.36 grams. But 3 sig fig, and I'm done. Whoop, whoop. Guys, I know it's hard. I do. God, do I know it's hard. Yeah, I do. These are level 9. This is the best. These calculations right here are the best insight that I can give you into what it's like to do A-level chemistry. Is this from the test you gave me yesterday? Anch is one of my year 11s who helped me test run your test, folks. Don't ask him for any answers, though. Yeah, I'm watching you. Guys, I'm going to leave you be. I will post on the classroom your excess reagent homework, and you can have a go over the next couple of days. Like I said, I hope I said, gotta go, bye. I hope you all have a great rest of your day. Can you give us the answers? I'm sure he's asking, Ange. You're very welcome, Tong. Guys, have a good rest of your day. It's been so nice to see you all. Take care. I'll post the questions on the classroom. Have a go at them. And then on Wednesday. Let's check that. It is, isn't it? It's Wednesday. Yeah. Next Wednesday is the big day. We will have a go at doing the questions, the test online. Guys, have a great day. Take care. Miss you loads. Bye now.